Hola, chaps. Let's learn. Hola, chaps. Mr. Turek here. This is for physics, but any of you can do this for fun. There's an activity called blind spot. And if you want to do this at home, it's pretty easy. You take a blank sheet of paper and put a dark X on it in one spot and put a dot on it at a different spot. On this particular handout, the distance from the X to the dark spot is about 2.5 inches. So I suggest that you have it something like that, similar to scale. And what you do is you look down on it. So I'm going to try to show you a little bit better what I'm doing and maybe make the contrast a little bit less on this so it doesn't glare so much. All right. So what I'm doing is I'm looking down from above the sheet of paper where my eye, and I'm only using one eye, so close one eye and put your eye directly over one of the X's and then move your face towards and away from the X, always looking at the X. There will come a spot where the dot disappears. And I see that I kind of set this up for my right eye, and I'm using my left eye. So when you're using your left eye, have the dot to the left of the X. So turn the paper over, and you'll discover, lo and behold, that while you're looking at the X, there comes some magic distance from the paper where the dot will disappear and be completely invisible. And for your right eye, have the dot to the right of the X, which I suppose you could almost see with this. And same story. Here I'm going to take my glasses off, but it's really not a good idea. You should do it with your glasses on. And so at this magic distance that you can kind of see on the camera, the dot disappears for me. So that's the blind spot activity. Now, what you could do with the help of a sibling, no doubt, someone in your home, is that you can take a small piece of brightly colored paper. And here's one I just cut out from a message I'd gotten. And they can take a pin and push the paper around while you are staring at the blind spot. And I suppose I could go like this a little bit. So you're looking directly at the blind spot, and your sibling is using a pin to push this little piece of brightly colored paper around. And what you're trying to do is have them say, yeah, I can see it. No, I can't. Yes, I can. No, I can't. And as a result of that, you're mapping out the region where the blind spot exists as you look at things. Okay, so this is a fun activity you can do at home. But wait, there's more I'm going to add to this. So this was this business of what you need on hand to do it. A sheet of white paper, put an X on it, make a dot about 2.5 inches apart from it. A second X, a region of the paper, a sibling, and a pin, and a brightly colored piece of paper, and you can map out the blind spot region for your own eye. But there's more, all right? So along with doing this activity, and if you only have YouTube and you want to, copy this screenshot and then print it, there you go. Here's the next screenshot. And I'm just showing with a ruler that I made the distance from X to dot about 2.5 inches, and then somewhere else on your otherwise blank sheet of white paper, put a big X, and that's where you're going to be mapping out your own blind spot activity. All right, but wait, there's more. So here's also an activity, and I'm going to move my webcam out of the way so you can copy the screen for a moment. And it's very simple. It says if you have a light bulb, an index card, take a pin and use your eye. And what you're going to do is put a small hole in the index card and then hold the pin up. So let's say the top of the pin is pointing upwards towards the ceiling. And as you look at it and move your eye around with the pin between the hole in the index card and your eye, you will see an upside down image of the pin. Okay, so exciting, fun, something you can do at home, and you're encouraged to do this so you get to use this pin twice. But wait, there's more. There's one more activity you could do with this for fun, and it's to build a pinhole camera. So here is the credit to the Wikipedia image I took offline. Here's a hyperlink to a JPL website that guides you through the process of building your own pinhole camera. The idea is this: rays of light travel in straight lines in a uniform medium, such as air or the vacuum of space. And so here's a tree. If you have a small pinhole in, let's say, a cardboard box, then the rays of light go straight through that little pinhole and show up on the back side inside of the cardboard box. Now, this is very difficult to do, but it can be done, and the JPL says, okay, use a small sheet of aluminum foil, make a small pinhole in it. The smaller the pinhole, the fainter the image, but there's also a trade-off between how faint the image is and how sharp the image is. Now, with a normal lens, you have to set the distance that it focuses at. So even on your cell phone, when you zoom in on something close, that's in focus and the background is blurry. And when you focus on something far away, the far away stuff is in focus and the nearby stuff is blurry. Well, with the pinhole camera, there's no lens and it doesn't have that disadvantage. Everything near and far is equally sharp, or if your pinhole's not quite the right size, equally blurry. So, this is a fun thing you can do at home. I've done this several times, particularly whenever there was a solar eclipse coming up. This is a cheap way to look at the moon and blocking out part of the sun. You can also do this by just going outside and looking on the ground underneath a tree, and the leaves act like natural pinholes, letting just little bits of sunlight to go through. And on the ground, you'll see these circles of light. That is the image of the sun. Now, I checked this morning. There haven't been any sunspots for the past 20 days. So there was a sunspot apparently seen about 3 weeks ago, but today there is none. And there's a headline article that suggests that April might be the month of solar minimum for this entire cycle. So that means, yikes, your likelihood of seeing a sunspot is pretty slim these days. But I've built a pinhole viewer for looking at the sun, and the image of the sun is going to be really small in a shoebox sized pinhole uh, camera. So if you can find a really long cardboard box, put a pinhole in the narrow end of it, have an opening where you can look into the cardboard box without letting in lots of light. So your eyeball has a view of where the image of the sun is coming through on the inside opposite narrow end of the long cardboard box. You'll see a little bright circle that represents the sun. It's still not going to be very large. Now, the US government has built something like this that is, well, let's not even talk about that one. Let's talk about Griffith Observatory. If you ever go up to Griffith Observatory, they have a camera obscura room, they call it, a pinhole that's using a periscope to bring the light into a darkened circular room. And when you look on the wall, you can see everything that's going on outside. It's in color, it's sharp, and it's a living image of what's going on outside. It's not a photograph. And so that's the fun thing you can do with a pinhole camera. In the old days, in the science building, we used to take a huge sheet of black plastic and cover up the windows. There's only one location in that building, the window that goes into that classroom, and have just a small pinhole on it. And sure enough, on the opposite side of the classroom, you can see the sidewalk. You can see students walking around. That's the image being projected on the opposite wall of our classroom. So this is something you can try to do at home. If you happen to have a room that you can make it very dark, except for one pinhole of light coming through from outdoors on a bright sunny day like it is today, on the opposite wall, you should be able to see an upside down living color image of what's going on outside. So have fun with that. Ciao.